Hi, I'm Andrea Elia, and today I will be teaching you how to answer the question on page 345, question number 10, A through C in the Advanced Function 12U textbook. The purpose of this video is to understand how to graph and write equations for trig functions. This is in Unit 4, and we can recognize that it's in Unit 4 when radians are involved in graphing sine or cosine functions. Just a quick summary before we start. Radians is a unit of angle equal to an angle at the center of the circle whose arc is equal in length to the radius. Math Open Reference, page 1. A pendulum swings back and forth 10 times in 8 seconds. It swings through a total horizontal distance of 40 centimeters. Sketch a graph for 2 cycles beginning with the pendulum at the end of the swing. So before we start, I want to run over the steps with you. Each step will be numbered, so when I'm doing the problem and explaining it, you can look at the top left of the screen to see which step I'm on. It should be right here. And at the end of the problem, I'll summarize everything that I did in order to answer the question. I'll do this for each question answered, and I also highly suggest that after I explain the steps, you try and answer the question first before I reveal to you how I got my answer. This way, it's going to be more embedded in your memory on how to complete questions that are very similar to this. Okay, so step 1 is find your range for the y-axis by extrapolating from the question. Step 2 is to find your x-axis range, multiply the period by 1/4. Step 3, label the x and y-axis. Step 4, label the x-axis depending on the amount of cycles taken. Step 5 is draw a positive cosine graph, and step 6 is give the graph a title. Okay, so go ahead and pause the video, and I want you to try and answer the question before I do. To start off this question, you must draw a graph. Although because in the question it states a total distance of 40 centimeters, and we know that a pendulum has an equilibrium point, i.e. the middle, our y-axis will consist of positive 20, 0, and negative 20. The labeling for the y-axis is distance traveled in centimeters. And don't forget to put your units in. The x-axis is represented as time in seconds. Now because the pendulum traveled back and forth in 8 seconds, the period can be represented as 8 divided by 10, which equals 0.8 seconds. This number represents 1 cycle for the pendulum. To find the range for the x-axis, you take 0.8 seconds and multiply the number by 1/4. This number comes out to 0.2 and represents the points of intersection on the graph. Note that between every cycle there are 3 other numbers which consist of adding the range by itself until it reaches 1 complete cycle. In this case, our domain is represented as 2 cycles, so our graph will end on 1.6, i.e. 2 times 0.8. Now that we have the x and y-axis labeled with our scale, we're going to draw a positive cosine graph. Just a reminder from lesson 2, a positive cosine graph means it starts at the maximum and goes downwards. Okay, so it starts at the maximum and goes downwards. So in this case, our maximum is 20, and therefore the next point is at 0, and then negative 20, and so on. To finish question A, we will draw a line through our points and give the graph a title. I named it time taken for the pendulum, but feel free to name it something else. Describe the transformations necessary to transform y is equal to sine of x into the function graphed in question A. So the steps taken to solve this question first start off with understanding what a positive sine function is. Step 2 is refer to the cosine graph to determine where the sine graph will start. Step 3 is where the sine graph will start is called a horizontal translation. Step 4 is determine any other transformations, such as a vertical stretch, which consists of the amplitude, and a horizontal compression, which is the b value and the period. Alright, so in order to transform this graph into a positive sine of x graph, we need to locate where on our original graph a positive sine function would occur. So once again, if you've forgotten what direction positive sine moves in, I suggest you review lesson 2. But as a reminder, a positive sine function starts at the equation of axis, i.e. the k value or the equilibrium, and goes upwards. So in our cosine graph, we need to locate where the function is at the equation of axis and goes upwards. This happens at 0.6. Therefore, the first transformation is a horizontal shift to the right by 0.6. To check if there is a new horizontal compression, we will look for a point where the function goes from the equation of axis to the maximum value, which in this case is 1.4. Subtract 1.4 minus 0.6 to get 0.8. This means that our b value is the same. We know this because 0.8 is one cycle of the cosine graph, and one cycle represents the period. If the period is the same, we know that the b value is also the same, i.e. 5 pi over 2. Therefore, the horizontal compression would remain the same as well as the vertical stretch, i.e. amplitude, because the pendulum has a set distance it can travel. So furthermore, the only transformations that the cosine graph must do to transform into a sine graph is a horizontal translation to the right by 0.6. Question C states, write an equation that models this situation. So the steps taken to solve this problem start off with determining what values are the same from the cosine equation. So you have your a value, your k value. Your main equation is d of t is equal to plus or minus a bracket cos or sine bracket b bracket x minus h bracket bracket plus k. Your a value is your amplitude, your b value is your horizontal compression / your stretch, which can be calculated by doing 2 pi divided by the period. Your h value is your horizontal shift, your k value is your equation of axis / your vertical shift up or down. Step 2 is determine which values are different, and step 3 is creating the equation, making sure the positive and negative signs are correct. In this case, the a, b, and k values remain the same, but as I just said, the horizontal translation, otherwise known as the h value, has changed. When writing the equation, it will read as follows. D of t equals 20 sine bracket 5 pi over 2 bracket x minus 0.6 bracket bracket. If you notice, the 0.6 has a negative sign in front of it. This is because once you take it out of the equation, its sign flips, so it will be positive. Also take note that in front of the 20, or a value, there is no sign indicating it is negative because we drew out a positive sine graph. So that's it for question 10. Just a friendly reminder that these types of problems are essential in some careers, so it's important that you nail down the basics and more from now. From the top of my head, a career that uses sine and cosine waves would be an environmentalist recording wave movement, or even an individual studying seismology. But the point is that you're constantly going to be intersecting these types of problems on a regular basis without even realizing it. Just this morning, I bet you made a sound, and guess what? Sound travels in the form of a wave, which can be represented as an equation. Looking for more practice questions similar to this, you can reference lesson 3 on my YouTube channel. The link should be in the description below. You can also reference the Advanced Functions 12U textbook, Chapter 6, Trigonometric Functions, if you need more assistance on these types of problems. Thanks for watching.